Hey guys, so I'm Robert Cleary.
Yeah, and I'm Tassos Bayaslis.
So in this video, we're assuming that you've seen some other videos and you've reverse coded the items that are needed to be reverse coded in the data set, that you have R installed, you are familiar with installing a package and starting a package.
We're also assuming that you've probably engaged with the forum already and you've noted some answers to the questions on the practice sheet, so you have seen the questionnaire and you feel comfortable with the data and the questionnaire itself.
Yeah, and now we're going to start doing a factor analysis.
Yeah, so if I interrupt here, so we start from the factor analysis and the reliability analysis because, as we've seen in marketing and advertising research, most of the consumer data we get are part of what we call a psychometric scale. So in our case, we know, or you should know, and we know very well, the different psychometric scales that exist to capture attitudes towards advertising. In the present questionnaire, we have attitudes towards advertising. We also have attitudes towards the brand that is being advertised. We also have the concept of involvement towards a particular brand or advertisement. And finally, we have purchase intentions, which is something we are always interested in to look about advertisements. So before you start doing any kind of analysis or hypothesis testing, like ANOVAs, t-tests, or regression, we need to bundle these psychometric scales together to create what we call a factor, which is essentially a new variable that represents the whole scale as one object in this case. So that's why we're doing factor analysis now and reliability analysis as well.
Yeah, let me ask us a question there, Tassos, because one way to do that surely would just be to take an average.
Yeah, so technically speaking, and most psychometric scales started out as averages or as sums. So people would either take the average of the items or would just sum up the items, and they are therefore called summative scales as well. So most psychometric scales are supposed to be summative scales as well. But what we've observed through different research and studies is that usually when people fill in the different questions or items of a scale, they don't necessarily assign the same weight of significance on each item. So from multiple surveys, we have seen that the items that we see on the questionnaire have a different impact on the actual concept that we're trying to investigate.
Okay, right. So some items might count more, and if you just take a mean, you don't allow that to be
exactly.
captured.
Yeah,
I got you.
Yeah. So that's why we do factor analysis, and we use the analysis itself to produce the factors. Still to the day, if you actually want to be able to interpret the factors per se, we do still use either a sum or a mean as such.
Really?
Yeah.
Okay. Well, so let's. What we thought we'd do here is we're using a form of factor analysis called exploratory factor analysis.
Yes. Yeah.
And we had talked about this before, because one way to do that is to do it on all of the data set, the whole, all the items, and see what factors come out.
You could do that, yeah. The problem with that, as we were talking before, is that if you put all of the items of the questionnaire in and you try to do the factor analysis, some of the items might not fit. And if you start taking items out, then when you come to hypothesis testing, it's possible that the relationships you see between the different factors are not there because the concepts that you present are actually related in that degree, but the relationships are there because we have created the factors in such a way that show the highest possible relationships.
So would anybody in branding and advertising research run a factor analysis on all the items? Like, when would that happen?
So that happens in certain cases when you are trying to figure out which items are completely and utterly independent from the rest of the questionnaire. So if you are trying to create a new measurement scale and you have a lot of items that can create a questionnaire by itself, so then you have to weed out the different items, so then you would use the whole questionnaire as an input in the factor analysis.
So like in the Zakowski paper that the students have read, where she's developing her own scale of involvement, you might run a full EFA exploratory fraction analysis.
And I think Zakowski's paper actually discusses that they actually started with, I don't know, 200 items or something, and they eventually came down to 20, and then they eventually came down to 10. So they do that definitely there.
Okay, but we're not going to do that. We're just going to look at one factor which we've almost justified theoretically, in a sense.
Exactly.
The survey was designed to measure purchase intention through 5 items. So we're going to look using factor analysis to see how reliable does it measure them.
Exactly.
And then can we create that one score for each respondent that summarises all 5 of those statements. So what we've done is we've already loaded the data. We've reverse coded the items that we need to reverse code. We've created an object called purchase intention, and what we've done there is we've said purchase intention is a combination of the columns in the data frame numbered 28, 29, 30, 31, 32. And we can now use this object to start doing our factor analysis.
Great.
So to do the factor analysis, we can't just do that in R. Well, that's not true, because actually you can do a baby version of factor analysis in R, but it's probably not as good as what we want to do. So we can use the package psych, which we talked about in previous videos. So you remember that to load a package, you've got to type library and then the name of it. And if you've got it installed, you shouldn't see an error message. If you don't have it installed or you've not installed it correctly, you'd see an error message, or if you spell it wrong, you might see an error message. Once we've loaded that library, now we can use all of the functions within psych on any object that we want to. So the first thing we're going to do is we'll try building a little factor analysis. So we'll create an object that does that factor analysis.
So we created an object called model 1, I'm assuming, because it's our first model.
Exactly. And so later on, the students, if you wanted to compare different models when you take items out, so you might have one model called model 1, one called model 2, and you could do an over on them and see which is more reliable. And so we're going to say use this little function in psych called FA.
So factor analysis.
So you could, if you really wanted to, write psych : FA. And what that would be saying is from the package psych. Use this function FA. But because we've only got psych loaded, we don't need to do that. And then if I remember how to do it correctly, which we'll find out in a minute, we're going to say use our data object D, but we only want to use the rows, so everything on the left hand of the column, and we want to use the columns from purchase intention. We're going to just have one factor. If we wanted multiple factors, we might write 3 or 4 or whatever, and that might be theoretically justified or statistically justified, and I'm sure the students would have covered that in some research training previously. And then we're going to use maximum likelihood.
Let's use maximum likelihood for now.
So what's the reason behind maximum likelihood? Why do most people use that?
So maximum likelihood.
Do most people use that? I made a
not necessarily. So in factor analysis, in marketing at least, we have 2 methods that are mainly used. The one is called principal components analysis, and the other one is maximum likelihood, as we're using in this case. And we're using maximum likelihood because, exactly as the name of the method suggests, it tries to maximize the likelihood of the item to belong in the factor that we are trying to create. So we're trying to achieve an optimal outcome in that sense.
What else could we use?
There are a lot of different methods that we can use. PCA, the principal components analysis, is another one, and then there are several other methods that are available in the psych package or in SPSS, like unweighted least squares, list squares, or even more complicated methods. The choice of the method usually depends on what you want to do with the data, what exactly it is that you want to do with the data. Some textbooks discuss some of the methods. Some of the methods are old in certain packages like SPSS. So there's always an element of researcher judgment as well that takes part.
Is there a one that's most common in?
So as I said, in marketing, you will either see PCA or you will either see maximum likelihood. Okay, it's one of those two.
And we thought we'll try and do both on this. This video. So
and we can compare the two models as you were saying before.
Let's see if we've done this correctly.
Before we continue, can you tell me what are these things after FA? So the first one, I remember it's the D, it's the object, the data set, and then we're telling it what part of the data set we want to use. But what is FM and why do we need a comma there?
Okay, so when you call a function, so this FA at the start is the function that we are calling from the site
factor
package.
analysis as a function.
Then most functions have what are called parameters that come in brackets after.
Right. So these are a set of parameters as such.
So essentially you're calling a function, but you don't just want to call the function on nothing. You've got to tell it what you want it to do something with, and are there any specific variables or criteria that you want to set. So we've just talked about whether maximum likelihood or different methods. So and the structure of those parameters unfortunately isn't standard. So that's where you kind of have to do a little bit of trial and error, go and look at the online help, look at the instructions, watch some videos, whatever's best for you. But I know off the top of my head, hopefully, that for factor analysis, first it needs the data. And so we're giving it D, which is the object we created earlier, and we're saying out of D we want all of the rows, which is this bit on this side of the comma, and then the columns are the columns we've already defined as purchase intention, and then FM is the factor method, and we want that to equal maximum likelihood, and FM and ML, they're all just defined in the psych package instructions. So if you want to use a different method, you just need to go look in the instructions, see what it's called in psych, and type it in.
And are all the parameters outlined in the documentation?
So what you'll find in the documents is normally it will tell you the function, and then list the parameters in order.
Good.
Often if you don't include parameters, it will just refer to a default. So if you didn't include this factor method, I believe, and I think we tested earlier, that it uses a different method than the one we might like.
So for every parameter there's a default setting that if you don't call it up or if you don't write something different, it will use that default setting.
Or if you get it wrong, if you spell something wrong, you'll get an error message. So we might get an error message now. I'm getting nervous. Let's press enter and see what happens. So no error message, so that would lead us to think the model has worked. So you might be looking at that and thinking, well, where's the factor analysis? On SPSS it gives me some results.
An output immediately,
Why do you think that is, Teslas?
So I think the way R works is that the analysis is inside model 1. So what we need to do is essentially call out the object named model 1 and then we'll see the results of the analysis.
You're good. That's it exactly, Teslas. You're smarter than you look. So we talked about R being an object-oriented language. So we've created an object called model 1, and we've defined what that object is, but we haven't actually told R to do anything now to that object. So with many of these functions that we're using, you might just type summary, and summary is a function with a parameter, and the parameter goes inside the brackets, and the parameter we're going to feed it here is the object. And here it gives us a summary of the model.
Okay.
So do you want to talk us through this, Tassos?
Yeah, so let's go and see what we can see in the summary. So on the top it says, I'm assuming that's the command, we did a factor analysis using those parameters. Now, from the output, what we can see is that R is actually quite explicit in terms of what it has produced. So the first thing that it says is that the test of the hypothesis that one factor is sufficient was concluded and is significant. So because we didn't tell it how many factors we want, the setting, I'm assuming, is one factor. So it has tested whether one factor is sufficient, and then it gives us the degrees of freedom for the model with the 5 factors, as well as the chi-square, which is another indication of how good the factor is, and the chi-square is significant, so we have enough observations to create the factor. Now we get several metrics as such. These are called metrics for the factor, so all these tests that they do are called metrics. So the first one is the RMSA, the root mean square of the residuals, as well as the degrees of freedom for the corrected root mean square of the residuals. Ideally, you want this root mean, the RMSA, to be low. So what the RMSA shows us is if we create the factor according to the analysis and then we compare it to our live data, how much residual variance we have left over. And obviously you want that leftover variance to be as low as possible. So
is it right in thinking it's almost what variance hasn't been explained by our factor?
Yeah, it's almost what variance hasn't been explained by our factor. Now, R is good, as you were saying before, Rob, in this sense, because it actually produces the Tucker-Lewis index of reliability. This is not a metric that is produced by most common software. It's called the TLI metric, and it is a very good reliability measure of the factor. We will also see the Cronbach alpha, which is something we more normally or usually use in marketing. But the TLI is as strong, and in fact, in certain cases, especially when you have a very big sample, the TLI is more robust than Cronbach's alpha. So the Tucker-Lewis index gets different values. The current value is 1, which is really good. And then
what would be a bad Tucker-Lewis score?
So the lower the TLI, the worse the fit between the variables is. And then we get the RMSEA index and 10% confidence intervals for the RMSEA index, as well as the big index. All these kind of indexes are indexes of how much information we've taken out for our data, from our data. So the RMSEA index is the root mean square error of approximation. It's very similar to the RMSEA on top. So these two indexes need to be similar or very close, otherwise there's some kind of problem with the model. And indeed here we see that the RMSEA is 0. It's really close to the 0.03. So we are happy with that. We see that the confidence intervals are 0 to 0.124, which means that that's the range where our RMSEA index fluctuates between. And again, you want these intervals to be as close to each other as possible. And the big is the Bayesian information criterion index that shows us how much information we've gotten from our model. The big is again similar to the TLI. The higher the number, the more information we have extracted. The lower the number, the less information we have extracted. Both the TLI and the big by themselves do not necessarily give us all the information. We mostly use these two indexes to compare different models.
Okay.
So if we run different factor models, then we can use these two indexes to see which model is the best, and it would be the one with the largest scores in these two indexes.
Are they relative? Do they only make sense if you're comparing like for like?
Yes,
so
they only make sense if you're comparing like for
so
like.
the 1.006 isn't good or bad in and of itself.
No.
It would only be good or bad in comparison to a different model using maybe 3 of the items rather than 5 of the items, for example.
Yeah.
Okay, so we've looked at the summary, but there's a lot of information there, and it's a good summary of the model.
Yeah.
We talked about wanting to see whether particular items in our scale are more important than others. That, I think, is what we call factor loadings.
Yeah,
so
exactly, the factor loadings.
There's 2 ways you can do that. You could type in $1 $loadings.
Okay.
And I know this because I've read the documentation.
Yeah.
And what it's going to do is say, show me the stuff inside the object called model1, which has been defined by psych as loadings.
Okay. Right, okay. So that's quite interesting then. So here we get a couple of interesting things. We get the loadings, of course, which we need to carefully examine and decide whether we will keep all the items or not. And then we get a combined measure regarding the variance that the loadings represent and the proportional variance that our model explains. Now, the proportional variance may seem a bit low at 46% essentially, but actually in social sciences, anything over 40% is a good start. And depending on the scale, you might get lower or higher. And other things play a role in terms of variance. So the sample size that you have, the actual number of items that you are factor analyzing, the distribution of these items, and so on and so forth. Now, in our case, the interesting thing is that the item PI2 has the lowest loading of the rest with a huge difference. So we can see that all of the other loadings are about 0.7 at least, with 1.8, but PI2 for some reason is 0.13. So we need to examine why that is the case. Should we do it now, or?
Well, let's not, because this video's getting long. But what I wanted to just finally show before we think about how you might maybe remove that item or investigate it is another way of just looking at the results of the model is just simply to call the object. And if you do that, you get lots and lots of stuff. You basically get everything that we just looked at as a summary and loadings. So a good place to start once you've got the model is just call the object and you get all of this information all together. But because we don't want these videos to go on for too long, we'll stop now and then we'll come back and think about the tests of reliability.